Good morning, students. Today we are going to start our next chapter, application of derivatives. Okay, so here we have studied about derivatives. Differentiation. You know the derivatives of different functions and how will you solve problems. Okay, we have studied in your previous chapter. Okay, and now the application of derivatives. Okay, from the name itself we have studied dy by dx, that is the derivative, right? Okay, and where y is a function of x, that is the basic of derivative. Okay, so here we are applying, okay, applying derivatives to the situations. Okay, that means in our practical situations or in various levels of questions. Okay, various levels of questions means you will understand it by the following. Okay, I mean the when we start the chapter, you will find it. Okay, that is, you have studied the derivatives of trigonometric functions, inverse functions, also the functions which is which is explained in terms of other function. Okay, and successive derivation, first derivative, second derivative, etc. Okay, and nth derivative, you have studied it all. So let's start the chapter. First application of derivative is tangents and normals. Okay, you have studied, you know what is a tangent and normal. Okay, so tangent and normals. The geometric representation of dy by dx, you have studied it, that is y is equal to f of x be a continuous function, and you have seen that dy by dx at any point p of xy of the curve y is equal to f of x represents the slope or gradient of the tangent at the point p. Yes, in the previous chapter we have studied, yes, the geometric representation of dy by dx, which is the slope of the tangent of that point. Okay, and what is a continuous function? Yes, continuous function means in a graph, graphically or geometrically it says, we draw a graph, the curve has no discontinuity. Okay, look at that figure. Yes, the straight line is drawn, that is the slope. And look at the curve. Yes, p of xy, the point is noted there. That curve is the continuous function. So it is continuously going. There is no break between, no break in that curve. That is the continuous function. You have to know that. Okay, so that is the continuous function. And yes, tan psi, that means psi is the slope of the tangent at xy. That is the derivative dy by dx. Okay, and psi is the angle that makes with the positive x-axis. Okay, makes that slope makes with the positive x-axis is the angle psi. Okay, and now if the tangent is parallel to x-axis, then psi is 0. Why? Yes, tangent to x-axis means the angle is 0. So dy by dx is tan 0, which is 0. Okay, so when the tangent is parallel, the derivative is 0, and when the tangent is perpendicular also, okay, the tangent is perpendicular, then psi is 90 degree. Okay, that is tan 90 is 0. Okay, so dy by dx is 1 or dy by dx is 0. Okay, yes, tan 90 is 1 infinity, so dy by dx is 0. And if we take the reciprocal, dx by dy, which is 1, that is given there. Okay, and that is the geometric representation of dy by dx. It was just a recalling one, okay? Yes. And next, the equation of the tangent and normal at any point of the curve. Equation of tangent and normal at any point. Okay, here the figure is given and the curve is given and the point P of x dash y dash, that is the point we have taken for the curve y is equal to f of x. What is y is equal to f of x? It is a parabola, okay? That you know that it is a parabola, so that is drawn there, and P is x dash y dash, the point is marked. Then the equation of the tangent at P is y minus y dash is equal to m into x minus x dash. Yes, that equation you have known. Yes, you have studied in the previous class, previous year. Okay, y minus y dash equal to m into x minus x dash. Okay, and where where m is the slope of the tangent at P. Small m, which is the slope, which is denoted as the slope. So the value of dy by dx at P is dy by dx at x dash y dash. Okay, so you have to first find dy by dx x dash y dash. Okay, that is given. That is the slope of, that is the tangent. And now for normal, the slope would be minus 1 by m. Minus 1 by m. This all have been studied in the previous year, so it was just recalling. We have recalling that. For normal, the slope is minus 1 by m. So, minus 1 by dy by dx of x dash y dash. So, the equation of normal at P is y minus y dash is equal to 1 minus 1 by m into x minus x dash. Okay, where m is dy by dx at x dash y dash. Okay, this is the equation for the slope of tangent. The equation for the tangent and equation for normal. So equation for tangent is y minus y dash equal to m into x minus x dash, where m is dy by dx at x dash y dash. And for normal, the equation is y minus y dash is equal to minus 1 by m into x minus x dash, and here m is dy by dx at x dash y dash. Okay, and the figure is given. Yes. And the working rule, if you have to solve problem, the rule is given. Okay, first differentiate the equation of the curve and obtain dy by dx. For doing problems, you have to first do, the curve is given. Yes, the given curve is, you have to do the first derivative. Okay, and then substitute in this curve, in this coordinates of the given point, that is x dash y dash. The given coordinate is x dash y dash. You have to substitute that in dy by dx. Then you will obtain the value of dy by dx at the given point. And this gives the slope m of the tangent at the given point. Okay, so you have to first find the derivative and then substitute the values of x dash and y dash in that equation, in the derivative, the required derivatives, and then that is the slope, and then substitute it in the equation of the slope. Okay, and take the negative reciprocal. For finding normal, take the negative reciprocal, and this gives the slope of the normal at the given point. And use the formula y minus y1 is equal to m into x minus x1 to write the equation of tangent. And for normal, we have taken the reciprocal, so this equation is also applicable. Okay, yes. So here I have given an example. Find the slope of the tangent of the following equation. Y is equal to x cube minus x at x equal to 2. That is the equation. So first you have to find dy by dx. What is dy by dx? It is 3x square minus 1. 3x square minus 1. Then at x equal to 2. So here x is 2. Y is no, we have, yes. So x is 2. So substitute the value of x. So that is 3 into 2 square minus 1. That is 3 into 2 square minus 1, which is 11. That is the required slope. Then directly substitute in the equation. What is y minus, yes, which is the required slope. Oh, okay, just you have to find the slope only. Okay, so you have to find the slope. For the next equation of also, y is equal to 2x square plus 3 and 2x square plus 3 sin x and x equal to 0. So the derivative dy by dx is 2 into 2, 4x plus 3 cos x. Okay, so the required derivative is 4 into 0 plus 3 into cos 0. Cos 0 is 1, so the answer is 3. So the required slope is 3. Okay, this is how to find the slope. And find the equation of the tangent, next question, of to the curve x square by a square plus y square by b square is equal to 1 at x1, y1. Okay, yes, first you have to do is to find the derivation. Find the derivative of the curve, given curve. Okay, so you have to find the derivative with respect to x. What is that? Yes, 2x by a square. So according to with respect to x, a square is a constant. So 2x square by a square plus 2x by a square. 2x by a square plus 2y by b square into dy by dx. Okay, dy by dx, which is equal to 0. Which implies, what is dy by dx from that? Yes, is equal to minus b square x by a square y. What is, we are doing the cross multiplication method. Okay. No, cross multiplication not, it is not the cross multiplication that you have to just move that 2x by a square to the left, to the right, and then it becomes minus, and then cross multiply 2y by b square. Okay, that is. And the slope of the tangent at x1, y1. The given point is x1, y1. So substitute the values x replace the values x by x1, x and y by x1, y1. So it gives dy by dx at x1, y1 is minus b square x1 by a square y1. Okay. Then equation of the tangent at x1, y1 is y minus y1 is equal to, substitute the value of dy by dx. Replace, that means in the place of m. So minus b square x1 by a square y1 into x minus x1. Or cross multiply a square y1 into y minus y1 plus b square x1 into x minus x1 is equal to 0. Okay. And this can be written as, okay, that is x1 terms, y1 terms, and then constant terms. Okay, we have just simplifying the equation. Okay, so we get x1 by a square plus y1 by b square is equal to x1 square by a square plus y1 square by b square. For that you have to open the brackets and then and then rearrange the terms. You will get this answer. And then by equation, by the question, we have given that x1 square by a square plus y1 square by b square is 1. So that a right side becomes 1. So the equation of the tangent is x1 by a square plus y1 by b square is equal to 1. Okay. Substituting that, you will get, this is the required equation for the tangent at x1, y1. Okay. Similarly, you have to do this problems like this. Okay, you can solve any problems. Okay. Yes. Okay. Okay, so this is the equation. Next is, find the equation of the normal at the point am square am cube. Okay, and the curve is ay square is equal to x cube. So as in the previous question, we have to differentiate with respect to x and then substitute the point am square am cube in that equation, and you will get the slope take the reciprocal or directly substitute. If you have not taken the reciprocal, you can directly substitute the negative of 1 by m, okay, to the equation, and then rearrange the equation, okay, simplify the equation, you will get the answer, okay. Next is the exercises, finding the slope of the normal, equation of the tangent and normal, okay, that type of questions. Many curves has been given, point and also given for you, okay, find the equation. This is the exercise. And next is the increasing and decreasing function. Increasing and decreasing functions. The term increasing and decreasing and constants, okay, that are used to describe the behavior of the function over the interval as we move from left or right of a graph. Okay, that means, that means if we draw a graph, okay, and the function is decreasing or increasing, or which is a constant, is find out by the shape of the graph. Okay, so look at the figure there. Graph is drawn and it is in a this shape. That means it is increasing first and then decreasing and then again increasing, and it is a straight line, which means the first is it is a increasing, it going upwards, so it means it is increasing, and then at some point it is there, and then it is turning downwards, okay, then it is decreasing, and then and again increasing, and it is a straight line going parallel to the x-axis, which means it is a constant, it is not changing, that means it is a constant, okay. So this is how you will identify a graph, okay, it is increasing, decreasing, or it is a constant. As the same, it is the behavior of the function over the interval. We can say it is increasing and decreasing, or it is a constant, okay. And then as in a function, okay, a function we have saying over an interval. Interval means, yes, it is starting at some point and it is ending at some point. The interval is between, and the 2 points, there are infinite number of points between that, okay, that is the interval, okay. How will you say a function is increasing or decreasing at an interval, okay, that is going to study. Look at that second figure. Yes, a curve is given, a function is given there. Y is equal to x square, okay, y is equal to x square. What is the peculiarity of that function? Yes, it is, function is first decreasing, right? That means it is starting from the origin, okay, in the positive axis it is increasing, and the negative axis it is decreasing, okay. That is the direction of that function. It is decreasing, and that it is coming at the point origin, and then it is increasing. That is how this function is, okay. And then increasing or decreasing functions are called monotonic functions. And the property of increasing or decreasing of a function is the monotonicity of the function. So in the case of functions, we have saying increasing and decreasing function as monotonic functions, and that functions increasing, and that property is called monotonicity of the function. So in graphs we have saying otherwise, and in a function, okay, in theory we have saying this. And then, okay, that is they are given, and look at that graph. F of x is equal to x square decreases on the interval minus infinity to 0. Is it right? Yes, because it has negative values. Minus infinity to 0, the graph is decreasing, and at 0, 0, yes, at 0, 0, the point is constant. That we have not taken. And then 0, infinity, yes, it is increasing. And in the closed 0, open infinity. Why it is open infinity? Because it is infinity. We have not taken a particular point at the infinity. That is, it is going. Okay, that is because it is a open. So, closed 0, open infinity. But it is not monotonic on minus infinity to infinity. It is not monotonic on minus infinity to infinity. It is monotonic in these two intervals. Okay, this is the difference between function and a function. Monotonicity of a function and in a graph. In a graph, it is easily determined, but during function, you have to find the interval. Okay, that is the difference. And next, and now the definition of a monotonic function, that means it is increasing or decreasing or a constant. That is, let f be defined on an interval. Always function is defined on an interval, and x1, x2 denote numbers in that interval. Infinite numbers are there, so take two numbers x1, x2. And f is increasing on the interval if f of x1 less than f of x2 whenever x1 less than x2. And f is decreasing on the interval if f of x1 greater than f of x2 whenever x1 less than x2. And f is constant on the interval if f of x1 is equal to f of x2 for all x1, x2. Okay, so this is the definition. So we have taking x1, x2 if x1 is less than x2. F of x1 less than f of x2, which means the function is increasing. Okay, and f of x1 greater than f of x2 means the function is decreasing. And f of x1 is equal to f of x2, the function is constant. And it is clearly demonstrated as a figure, graph. Okay, yes, that is the definition. And proving monotonicity. Okay, some examples have been given. Without using derivative, show that the function f of x is equal to 3x1 plus 1 is increasing or decreasing. Okay, so for that, you have to take 2 points. So let us take x1, x2, 2 points. And x1 is less than x2, then 3x1. 3x1 means, yes, 3x1 multiplying with 3. So 3x1 less than 3x2 and adding 2 side with plus 1. Adding 1. So 3x1 plus 1 less than 3x2, which means, yes, f of x1 less than f of x2. So the function is clearly increasing. Okay, here just we have taken you have to find it is increasing. So can we derive it as an increasing function? That is given. So taking x1 is less than x2, just taking and arbitrarily 3 is multiplying and then adding it with 1. Then you have get x1 less than f of x1 less than f of x2. That's clear. Similarly, the next question. Okay. And also trigonometric functions can be find out it is increasing or decreasing. For that, given f of x is sin x. Okay, is increasing in 0 pi by 2 and decreasing in pi by 2 pi, and which is those closed intervals. Okay, so you have to find it. F of x is equal to sin x, then f dash x is cos x, and it is positive in 0 pi by 2 and negative in pi by 2 pi. So f of x is increasing in 0 pi by 2 and pi by 2 pi. Okay, that is the given. Similarly, the second, third and fourth questions. Okay. And next is the finding in the intervals. How will you find the intervals of increasing or decreasing functions? For that, first question is x square plus 2x minus 5. First you have to find the first derivative, 2x plus 2. And that is less than 0. Checking that it is less than 0. And then x plus 1 less than 0. Okay, how will you find x plus 1 less than 0? That is x equal to minus 1. So here f of x is decreasing for x less than minus 1 and increasing for x greater than minus 1. So in this definition, f of x is decreasing in the function x less than minus 1. So minus infinity to minus 1. and it is increasing in the interval -1 to infinity. We can say that. I think it is clear. Okay. Yes. Similarly, the second question also. Okay. Find the first derivative and then it is, if it is less than 0 or greater than 0, that's the one. Okay. And then the exercises. You have to show that the given functions are decreasing, increasing, and if it is a constant function. Okay, and you have to find the intervals. Okay. Sorry. Similarly, these are the one, and here also trigonometric functions has been given. Okay, so you have to just go through this. Okay, so this is just you have to solve problems. Okay, that is tangents and normals, and then increasing and decreasing function. These are the important topics in application of derivatives, and I think all of you understood the problems. Okay, and thank you, students. Have a nice day.